residuals and interpreting a line. But first, I want to go over what we did in the past. So we had scatter plot. We had a scatter plot that had points that were scattered, hence a scatter plot. And we created a line using our calculator, which helped us find the linear regression. After we had our linear regression model, we were able to predict different things. So this example, we're predicting the amount of rubber bands we need for our Barbie. When we did the project, we did like calculators and hand sanitizer coming off of the ceiling. All right? And we also decided whether or not some predictions, we were confident in those predictions. And if we weren't confident, they were called extrapolations. So today, we're going to compare what we predicted to the actual point. And that is called a residual. So our best fit line, rarely do we have points that actually go through the entire line. We take each point and we try to find a line that best fits all of them. So what that means is that there are distances that the points are from the line. And that distance is our prediction error. If we could find the difference between the actual value and the value we predicted, that is what gives us what we call a residual. So for instance, if we look at this picture here, our regression line is what we have in blue. Our data point is what's in red. And the distance between the data point and the regression line is called the residual. And we calculate that by finding the distance. And since it's vertical, it's the difference between the y values. So, if you do not have anything written down, you need to write that part down. Highlighted, box it somewhere. A residual is the actual y minus the predicted y. Do you remember how when we were doing the classwork, I was going over to people and say, oh, make sure you have the hat over your y. Because if it doesn't have a hat, that means we're talking about the actual y. If it does have a hat, that means we're talking about the predicted y that's in our regression line. So be very careful with your variables. So make sure you know that the predicted y is the actual y. The predicted y is y hat, and that the actual y is just a regular y. So make sure you annotate that. I'll give you a moment. So you want to make sure that it's highlighted, boxed, starred. That part's important. Okay? All good? So class, remind me, what is the residual equal to? Thanks, human. Other humans. What is residual equal to? Thank you, more humans. Humans to my left and in front of me. I'm recording, so I'm trying not to say your names. What is residual equal to?
Actual
There you go. Remember, the more you say something, the more you write something, the more you do something, that's what helps your memory. Try not to rely on your notes entirely. Things like this, you should be able to remember, so that way you're not spending 5 minutes trying to remember what it should be. So remember, the more you do, the more you write, the more you remember. So every time we do a residual problem, I want you to write out the equation. The more you do that, the more you remember it. So a random sample of 16 used Ford F-150 Super Crew 4x4s was selected among those listed for sale at autotrader.com. The data are shown in the table. For these data, the regression equation is price hat equals 38,257 minus 0.1629 miles driven. Calculate and interpret the residual for the truck that was driven 70,583 miles. All right? So we know that the first thing we need to do is figure out what the predicted price is. Because we know, and I'm going to open this up and I'm going to write this down. If I was going to do this, the first thing that I'm going to write is I want to find y minus y hat. Okay? However, notice something. I don't know the y value of the predicted price. I know that the y value for 7,583, I know that this one is actually 21,994. That's what I know. You guys with me so far? So I have to figure out a way of how can I find what the predicted price is. Well, they gave me the equation. So I'm going to input the miles driven into my regression model, which will tell me, based upon the line that it will create, what should it be. So based upon the math, it should be 26,759. So I'll say that one more time for us. We know that a residual is y minus y hat. The y value came from the actual data. So I looked in the data. When my miles driven was 7,583, my price was 21,994. My predicted value I had to put in the actual equation to figure out what should it be based upon my model. Are we okay on that? Lovely humans? Okay. So now that we know what these two numbers are, we're going to subtract them. So in order to find the residual, we're going to subtract the two numbers. Now remember, we like negative numbers. Negative numbers tell us the direction. In science, you call it the velocity. So you want to make sure that you always do what the actual price is minus the predicted price, because that will tell you how accurate you were. Okay? So is our question or is our answer a residual? Is it positive or negative? What is it? It's negative. So I want y'all to just take a wild guess. If your residual is negative, do you think it's more or less than the actual? Less. Okay? So therefore, here's your answer. The actual price of this truck is $4,765, less than the cost predicted by the regression line with X equals miles driven. That is the answer I'm looking for. If I do not see at least this part, I want to know that. I want to know context. So you see that part that I just highlighted? If I don't get the context, I'll write that down. We want the context. Why? Or else Miss M is going to make up stuff. And I love making up stuff. I want to know the actual answer. And I want to know the interpretation. Or the meaning. If I don't have all three, you are not getting all points. If you don't give me context, I'm making it up. If your answer is wrong, we just need to math better. And if you don't give me the interpretation, that means that you didn't answer the question. They told you to calculate and interpret. So if you're someone who just likes to drop the mic and give me one answer, I'm going to drop those points as quickly as you dropped your mic. So once you write that, we're going to try a problem together, okay? Okay, class. Give you about 10 more seconds here. All right, y'all. Let's try the next question. This is an example that looks kind of like your book, okay? As a reminder, I give you these because they look like the questions in your book, but there are examples in your book that look like this that you can practice. Sorry. There are also checks for understandings in your book. Also, if I can be real with y'all, I noticed that some of you, when you did the section exercises, you just stayed in the answer key. That doesn't help you on quizzes and tests if you just look at the answer key for your section exercises. So you're kind of stopping yourself from being as great as you can be. So make sure you try the problem and then go in the back of the book to check to see if you're correct. Okay? Either way, you're going to get the same score, so you might as well have some integrity. So let's calculate and interpret a residual. Mrs. I would say her name is Gayas. Did you pronounce her name like that? I would pronounce it like that because Gallus sounds terrible. Okay. So Mrs. Gayas' class performed the Barbie bungee activity. In this activity, students made a chain of rubber bands connecting them one at a time to Barbie's feet, then measuring the distance that Barbie travels on her bungee jump. That sounds violent. The distance is measured from the edge of the jumping platform to the lowest point that Barbie's head reaches. Here's a scatter plot of the data from one of the groups with the regression line. Y hat is equal to 27.42 plus 7.21x added to the scatter plot. Find and interpret the residual for the trial with 4 rubber bands where the students measured that the Barbie traveled 52 centimeters. They said a whole lot, didn't they? You know what's crazy? What part do we care about, class? They said all that for what? What do we really care about? The answer, yes, but which part of the question do we really care about?
The regression line.
So I heard the regression line, and what else did you say? The last part. So other than the fact that you need the context, that's really all you need in this question. The rest of it is just trying to tell you what's going on. So what are we trying to find and interpret again? Nice. Okay, so we want the residual, okay? So let's break it down as simple as we can. Residual. How do we find residual?
The actual y minus the predicted y.
Got it. How would I write that in quick terms?
Y minus y hat.
Yes. So if you need to, write residual on the side. Because remember, the more you write it, the more you remember. So if you're like, oh man, miss, I forgot. Guess what? Keep writing it. You'll remember. You have to learn your own name somehow. You know how they taught you how to write your own name? They made you write it over and over and over again. Then they made you put it on your fridge and stuff. No? Oh, okay. All right. So now, do we know what our y value is? Do we know what our actual y value is? If they didn't, how can we find out? Take a pause for a moment. Don't focus on that. Focus on this. I'm trying to help you learn how to read through a question. So you show me the part that's actually the most important. Angel, are you talking to me? Sandoval? Are you communicating silently? Yes, you are correct, human. Let's make the other ones figure it out. All right. What numbers did they give us? Just shout them out. Okay, what does 27.42 have to do with anything? That's in the what? Okay, does that tell us our actual y value? No, so guess what? We don't care about that right now. Give me another number.
52.
I'll get to that one in a second. Let's go in order. Okay? But, yes. 7.21. We'll learn about what that represents in a moment. Is that going to help us find our actual? No, actually those two numbers are part of the regression line. Is the regression line the actual or the predicted? So do we care about those numbers right now? No, we can care less. Give me the next number you see.
4.
4. What does 4 represent? Okay. Now I want you to look at the graph. Is 4 explanatory or is it your response variable? Is explanatory X or Y? Ooh, let's go back. Think about it, humans. Explanatory. Look at the graph. It's X. You positive?
Yes.
It's Y. Are you sure? Don't trust me. I can't be trusted. I'm going to ask you regardless.
But isn't Y like the outcome? And then X will help you?
Humans, with your back to me, is Y the outcome and X is how you got the outcome? Yes or no? We're asking. Yes or no? Yes? Okay, so that means that 4 is your X value. What number do we have left? 52. Response or explanatory? Is response your X or your Y? So that's the actual Y value we have when our X value was 4, right? Congratulations, you found the actual Y. How do we find the predicted Y? Okay, what do you mean by that? Okay. You said 27.42x? Okay, so I just should write x? Like that? Okay. So keep working with it. Nice job. Is there a way I could make this simpler? Is there a way that I may know what x is equal to, maybe? What is my x value?
4.
4. Why did you use 4?
Because that's the number to. Oh, yeah.
Because what?
The number they gave us.
That is the number that they gave us for x. So remember, we're using the same value of x. There's two things that we're looking for. The one value of x, I'm going to make it green. That's the actual one. Like something like this right here. That's the actual one. However, the predicted one is if I follow the line, there should be one right here on this line. So we're trying to find the distance between it. How far away is it predicted from what it should actually be? So instead of x, I'm going to write 4. Okay, I need y'all to do some math and find me the answer. Yes. Not yet. Let me check how you put it into the calculator. Okay, so instead of brackets, put
Negative 4.26.
now interpret it for me. What does that mean? That means that the predicted price was what than the actual price? Or the predicted height?
It was 4.26 less than the predicted.
Now tell me what you're talking about. So that's the answer. Now put some context in it.
The trial with 4 rubber bands was 4.26 less than the cost predicted. It was
So I want you to put it in terms of y. So instead of talking about the rubber bands, I want you to talk about the distance traveled. So the predicted distance traveled was blank units less than the actual. I didn't know what those came out. Yeah. Did you interpret it already?
I got the number.
Nice. Give me the number and then remember, because that's only a third of the battle, right? Oh, did it leave us? That's good. I will put it back.
Yeah.
Yeah, but that number is different than mine when it was the first time. May I? We're missing something. Your number's off. Okay. See how you did it like this? Why is your number so big? Oh. Oh, this one? You okay? Did you do this part? The
part that I'm doing right now? Because if both of you tell me you're confused on what we're going to learn, and I'm going to tell you, oh, weren't you on password? Like, no, I was going to do on password, but I would have time to do another stuff. So now you're putting yourself doubly on. And I'm talking to both of you. So back to what did you try the problem? So I'm just supposed to be here waiting my breath for nothing? Did you try it? What does that mean? Right. That means if you owe me $4.26, I'll need you to run it by Monday. Oh, I'm sorry, you didn't give me any context. That's what I turned it off. I'm gonna need $4.26. Thank you. Progress, let's see. She about 4.26 feet. Dang, Louise, that's almost nothing. So, first thing, make sure that you always do the action first. So if you don't tell this one second. So it's 52 feet. Oh, okay, so that's not too bad. Okay. Now, if you're ready to show for a second, just checking in with everybody. Yeah, so just all you got is the number and the unit. Okay, if it over in centimeters.
I was about to print it, and I was like, you did the last time.
Because this is the actual number. I don't know where that. I mean, you checked your work. That's great.
Yeah.
Is this number that correct?
Only a residual, right?
Because what you gave was the actual number. What I care about for residual is the difference between the actual and the residual. So how far was I off? Did you do the context switch? Okay. Okay, check your mark again. What's up, my love? How can I help you? So once you have that, put it in the pocket. You're not doing anything. What is this? Iron free?
Alrighty, y'all, let's move on. Now, this is what I will say. If I can be completely honest with you, the ones that stayed with me got it, and they got feedback for the most part. There's only one kid. You okay? You need me to check it? Are you positive? All right. Now, those that weren't with me weren't able to get feedback on their answers. So I want you to keep that in mind about staying focused in class. All right? That means you missed out on that opportunity. All right, now let's move on. Let's talk about interpreting a regression line. Because you know that slope and that y-intercept, you know it means something, right? It does. Okay, so that green box is what's important. A is the y-intercept. This is the predicted value of y when x is equal to 0. If I can show you a quick picture, here's my line, E. Here's the y-intercept. This is always when x is equal to 0. So the y-intercept, I will also say that the y-intercept is the one without x. So when I look for that y-intercept value, that is my outcome when the x is 0. So for instance, for the Barbie one, that would be my distance traveled with 0 rubber bands. My y-intercept. Now, B is the slope. This is the one that usually gets students, so I really want you to practice this one with me. B is the amount by which the predicted value of y changes every time x increases by 1. So if you remember slope, the slope is the change in y over the change in x. So let's say every time x increases by every 1, I want to know what is that y. And we're going to put that in context. The good news is this context looks exactly the same every time. You just have to make sure that you know what goes with what. All right, pushing forward. Recall that for a random sample of 16 used Ford F-150 Super Crew 4x4s, the regression equation is price hat is equal to 38,257 minus 0.1629 miles driven. Interpret the slope of the regression line. Does the value of the y-intercept have meaning in this context? If so, interpret the y-intercept. If not, explain why. All right, so let's talk about this. First, can you tell me which number is the slope? Is it the 38,000 or is it the 0.16, the slope?
0.16.
Yes. Oh, your 9th grade teachers would be proud. Okay? That one is the slope. So, when we do the slope, we're very important. We really want to know what our y is and what our x is. Okay, so I'm going to do it in green. Okay, so let's just keep it in context. What is the y in context? What is it?
38,257.
Yes, but go a little bit more holistic, macro. Theme. Give me the theme. Like, what is that number? What's the context of it? Is it distance? Is it height? What does that number represent? No. They actually wrote it in words. Okay, so if you look at the equation, if I rewrite it using my variables, it kind of gives me a hint. Y is the outcome. That's what it's equal to. So what is y, class? What's the number what's the word that has a hat on it? So y means price. Okay, don't think too deep. Does everyone understand how I got price? If not, please tell me no. Like, for real, please tell me no. Okay, so then what is your x value? Miles driven. So what that means is we need to interpret what the price is for every 1 mile that we drive. Okay? And y'all told me that the slope is equal to 0.1629. Okay? Let's put a dollar sign because that's what price means, right? Over 1 mile. And class, just to be clear, is this a positive or a negative slope? Are they adding or subtracting? So is it a positive or negative slope? So if it's a negative slope, does that mean the price is increasing or is the price decreasing? Decreasing. So every time, and I know there's the answer already. So every time one drives a F-150, 1 mile, does the price go up or down? The price decreases. by $0.1629. That's the slope. So for each 1 mile, what happens? It went down, it was negative, and that's by how much? Does anyone need me to say that in a different way? Yes. Yes. Also remember, just I'm going to give you a sentence frame in case you need help with it. Okay. So here's my stem. As whatever your x value is, increases. Write this down. Now, when you say, Miss, I need help, I'm going to tell you to have this written down. So what that means is if you don't write it right now, you're going to have to look through the video. So if you want to give me the slope, you can always write something like that. As fill in x increases by 1, fill in the unit. Y increases or decreases by whatever unit. So make sure you fill in the parts that are in brackets and the parts that are blank. Oh, you need, yes, that's perfect. So the word 1 is always there. The increases by 1 always stays there. Psst. Write that down. I'm telling you, if you don't write it down, I'm going to be real disrespectful. I'm going to tell you to watch the video and find it. So this is something you'll see in college. A teacher will drop a fact on you. If you write it, great. If not, you missed it. And that's that on that. Okay. Give you about 10 more seconds. After this, I have only 2 more slides, 2 more things to tell you, and then we are donezo, humans. And you can take a nap, in theory. Now let's talk about your y-intercept. Your y-intercept is when your x value is equal to 0. Your x value is miles driven, correct? So I have a question. Can you buy a car that has no miles on it? Yeah, you can. It's a brand new car. Should you? That's up for debate. We'll talk about it later. Okay? So essentially that means that your y-intercept would be equal to 38,000 257. So a brand new Ford F-150, according to this model, costs $38,000. You know some teachers get paid $38,000? Not really in California. But there's no way, not in California. But that's like somebody's paycheck, and you just bought a car for that? A car that depreciates with time? Cha. Okay? So, our y-intercept makes sense. So therefore, since our y-intercept makes sense, we want to say, and this is very important, the predicted price in dollars has been driven 0 miles. Oh, so there's something that I missed in your other part. 1 second. You see that this part right here? Do me a favor. Add this, the predicted price, to the top. It's okay. I'll give you some time to go and fix it. Okay. So make sure you add the predicted price for me, please. And why are we using predicted price? Because a regression model is just a prediction. Okay. Can everyone write the predicted price? Yes, yes. Everyone's back from the bathroom? Yes? Okay, good. Okay. So that means for the y-intercept, the predicted price in dollars of a used Ford F-150 that's been driving 0 miles would be $38,257. A lot of money. It's a whole lot of money in that car. Okay? So here's the part that's very important to remember. If you're talking about linear regressions, since they're a prediction, you have to state that it's a prediction. Or else you're giving alternative facts. And do we give alternative facts? No. No, we don't. We're not going to lie. We're going to tell them exactly what it is. Sound good? That's all I got for you. Bless your spirits. We are done.